first part of today's session, which is going to be mainly focused on how to fix meshing errors using Feko. We'll start with that before hitting the second part related to CAD with Gopi. I wanted to start with a general overview about what is a mesh, and it's a basic definition. I'm sure a lot of you know already what it is, but it's always good to just remind what we are talking about. So basically, a mesh is a discretized representation of a given geometry we have. This could be a geometry model or a mesh model. So basically, it's a representation of the model that would be later used during the simulation and when we are running our solvers to be able to compute given requests in our simulation. And actually, it has a direct impact on the accuracy of our results because better it represents the geometry and the model, the higher accurate results we will be obtaining. So in CAD Feko, let's dive in a bit more into the terminology that we use. We have actually the geometry parts in general. They are usually model geometry and they refer to the CAD in the model. These CAD parts can be created in CAD Feko or they can be imported from other CAD tools in different formats. And we then have the mesh parts. So I'm going to show you a bit under in CAD Feko. This is the section under construct where you can see three different types of representations. So first we start with the geometry that has been meshed within CAD Feko. So it has a simulation mesh linked to it. We also have mesh models. So this icon refers to a model mesh that has been imported into CAD Feko, but also you can have a model mesh to be able to simulate that has a corresponding simulation mesh linked to it. So there are these three different terminologies that would help us later on identify what we are speaking about. So what we will be dealing with mainly today is how we can adjust or fix a simulation mesh when there are errors related to that simulation mesh. First, some of you might have already bumped into this type of errors or warnings that are directly pointing out to some mesh-related issues. These mesh-related errors usually point out the problem. So they would tell you what is the issue. Is it an overlap? Is it intersections? Are there some meshing criteria that have been violated and so on? Here is just a general list, a quick overview of the errors you can have, but there are yet much more. So the main idea is that when you get this type of error in your model, how can you address this issue and how can you try to fix these different types of errors? So there are two steps: finding the problematic parts and then trying to repair them. Now, within CAD Feko, there is a dedicated mesh fixing tool that you could find under the mesh menu. So you have a section related to finding problematic parts, and then you have some tools that allow you to repair those tools. So I will zoom in a bit more into the repairing part, because usually when you have an error in when you run your simulation, then you will try to overcome that. So there are some repair tools that are available in CAD Feko. And one of those tools is to create triangles. So mainly this is when the mesh contains holes or faulty triangles were deleted. You can use this tool to just fill up the part that was deleted or that is missing. Now, a second tool is actually a tool that helps you merge meshes. This is basically when you have imported two different meshes in your model and you want to perform to just merge them in one mesh. This is the equivalent actually of the union tool for CAD. And so this allows you to merge the separate mesh parts and to ensure that the elements of the two meshes are electrically connected, or it also helps to add edge ports between these meshes to also account for that connectivity. Now, there's also a grouping mesh part tool that can help you actually if you have one mesh of a big model, you would like maybe to split that mesh into multiple parts or to regroup parts in a given mesh based on label definition. And the last three parts, or let's say functionalities, are quite helpful. So the first one is helps you remove collapsed mesh elements, which means that it removes all elements that have degenerated or that, for instance, let's say, are a bit disformed, that have more than one vertices and so on. There is the second part, which is the remove duplicates option. And this allows you to, when using imported meshes, or if you have just performed some mesh editing manually, to remove all potentially duplicate elements in your mesh. And there is the last function, which helps you to merge vertices. So basically, usually the mesh connectivity relies on vertices of different mesh elements that are adjacent to each other to be almost the same or within a very small tolerance, and this allows to merge them if they are very close to each other. So the main idea behind all this actually is I'm going to go back a little bit to the errors that the list of errors. So usually in the errors, you just get right to the type of error you have, but you don't have more information about where it is, how you can find it, and how you can fix it. And for that, we're going to go through a very short demo with a model mesh that we will try to see and fix together and see what is the workflow that we currently can do in order to fix all that. The model we will be using for this demo is a satellite model. It is based on a model mesh that has been imported into CAD Feko, and at first sight we do not see any specific mesh-related issues. I will be performing an RCS simulation, so I have set a frequency of 300 megahertz for that, and I have defined a plane wave incidence over the azimuth directions that scans phi from 0 to 360 by fixing theta to 90 degrees. I have also accordingly requested the far field in the same incidence directions as the plane wave to obtain my RCS results. I will start by running the solver and observing the outputs in the run progress of CAD Feko. I see that the solver has straight away issued an error, and it is pointing out two intersecting elements that have been found. In the error message box, we do not have any further information, and it is telling us to check out the output file. So I will check that by running the post-Feko session of this model and checking out the content of the output file. This is my satellite model that I have just run, and I will import the output file to check the details. I see that in the output file, the intersections have been listed here. There are two intersecting triangles, and I also can see the ID of these triangles. How to find these triangles in the model itself? First, in post-Feko, you are able to check for mesh elements in the 3D view by going to the Mesh menu, under the Tools group, selecting Find Element, and here you can find elements based on their IDs. They can be triangles, they can be wire segments, or other types of mesh elements. I will be copying the triangle IDs that are listed in the intersections, and I will choose to add annotation. This will add a corresponding annotation in the model. I already see that here indeed there is a clear issue with these two triangles that are overlapping, but also that there is an empty space that should not be there. Just to double check that also the second triangle is the one below, I will also choose to add annotation, and I see indeed that the intersection is mentioning the triangles over here. Now that I have located the place of these triangles that I will need to fix in CAD Feko, I will switch to the main CAD Feko model and try to go. So it was the second blade here on the left, and indeed I see that they are here. So how can I fix these two intersecting triangles? I will try to delete one of them and just to recreate a triangle to fill up the hole that already is partially there and that will be bigger once I delete the triangles. So I'm selecting the triangle from the 3D view. I will delete it and I will use one of the tools I have showed you in the slides, which is the tool to create a triangle. You can either manually input the coordinates of each vertex of the triangle, or you can snap to the vertex you want to choose from the 3D model. And this is what I will do because it is quite quick and easy. So I will use the Control Shift snapping tool, filling up the second vertex and the third vertex. And now I see that I have a preview of the triangle that will be created if I confirm my settings. And now the triangle has been created to fill up the mesh error over here. Since no other errors were reported, we can try to rerun our model. I will save it as, and I will rerun the model. While waiting for the run to finish, I would also like to mention that this workflow, which consists of first checking out the element IDs that are involved in any type of mesh related error, whether it's intersecting elements or overlapping elements, or even sometimes you want to see you have an error related to the size of a given triangle and so on. You can identify the location of these triangles using the output file where you extract the ID and then you locate them as we did today. So this is not only a workflow that is used for this specific error exactly, but it's also valid for all the situations in which you will need to locate specific mesh elements. Now that the run is done, we will check the results in post-FICO and just confirm that all is good. So here we see our model, and I will plot the RCS and see that all went well with no issues or errors. And with this, we conclude this demo.